All right, so we're going to describe polynomial functions today. All right, so we're going to get to higher, we're going to talk about degree. We've seen linear, which has a degree of 1, and quadratic, where we have lots of x squared. So we did lots of quadratic stuff last 9 weeks. So start of a new 9 weeks, so let's get a good start today. All right, so polynomial functions. And this is a review from Algebra 1. Nick, pay attention, please. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. Okay? Whole numbers are 0 and up. Right? So we don't have any negative exponents for a monomial. Okay? Whole number exponent. A polynomial is a monomial or a sum of monomials. So our polynomial won't have any negative or fraction or variable exponents. It'll just be whole numbers, 0 through infinity in the positive direction. All right, and there's the form for a polynomial function. All right, a sub n of x to the n plus a sub n minus 1, x to the n minus 1, and so on. So we're going to put these in order from highest exponent down to the constant, the one that doesn't have a variable. All right, a sub n won't ever be 0. Okay, the exponents are all whole numbers. The coefficients are all real numbers. The coefficients are the numbers in front of the variables, remember. Okay? For this function a sub n, this blue one, that's why they wrote leading coefficient in blue. That's called the leading coefficient. It's the first one. When you put it in the correct order, the first coefficient is called the leading coefficient. N is the degree. It's in red here. So that first exponent, once it's in the right order, is the degree of the whole polynomial. So if it's x to the 5th, that first term, then our degree is 5. If it's x squared, like we've seen a lot of, then the degree was 2. So those quadratics that we did had a degree of 2. It says a polynomial function is in standard form when its terms are written in descending order of exponents from left to right. So we're going to go from the highest exponent in order down to the constant. That's standard form for our polynomial. Now you're familiar with our types of polynomial functions, our linear and quadratic. Okay? We've done lots of linear and quadratic so far this year. All right, so we're just going to get to x cubes and x to the 4th and x to the 5th with these polynomials. That's all. So here's the degree on the left, and there's the standard form, and there's an example. All right, the type we're going to fill in. Okay, when it's got a degree of 0, meaning it's just a number and no variable, all right, then it's called a constant. Okay, when our exponent is a 1, like this, 5x to the 1st, we just never write to the 1st power minus 7, that's linear, which we've talked about already, right? And then here's 1x to the 2nd. We've been talking about these already a lot this year too. Quadratics, you already know those three, okay? Well, instead of saying x to the 3rd, sometimes we say x what? Cubed, right? So when you have an x to the 3rd or x cubed, we call that a cubic polynomial. All right. So that shouldn't be too hard to remember. Now to the fourth power, all right, think about, musical stuff. When you have four people singing or four people playing an instrument, what do you call that? A quartet, right? Well, we call a polynomial to the fourth power or fourth degree polynomial a quartic. Not quartet, but close. A quartic polynomial. And you'll see a degree of 5, we'll add that one. Usually after 5, we don't have a special name for it. All right. But, given an example, we could have f of x equals x to the fifth plus, 5x to the fifth. I need an x to the fifth somewhere, plus 3. It doesn't have to have, 6 terms or anything. It just has to have an x to the fifth as our leading term. All right. What do you call, people that are singing or playing instruments that are in a group of 5? A what? Is it a quintuplet or something like that? I don't know. Is that what they call them? Yeah. We call this quintic. So those are the special names when you have a degree of 0, 1, 2, 3, 4, 5. If it's got a degree higher than 5, just say, if it's got an x to the 7th, just say a 7th degree polynomial. We don't have a special name for it. Okay? So remember, you're going to put it in order from biggest exponent down to the constant, the a sub 0 one. The one that's just a number and no variable. So those are our common polynomial functions, the most common. Any questions so far? Okay. So this example says determine whether each function is a polynomial function, first of all. If so, write it in standard form, in the right order, state its degree, type, and leading coefficient. Okay? So, do we have whole number exponents? Are our exponents 0, 1, 2, 3, 4, 5, and so on? Yes. Right? We don't have any fractions, no variables as exponents and stuff. So, yes, it's a polynomial function. All right. Write it in standard form. Is it in order from highest exponent down to the constant? So it's already written in standard form. So that part's done for you. State its degree. So what's the degree of it? What's the highest exponent? Or the first exponent? 3. Yeah. So it has a degree of 3. All right. If it's got a degree of 3, what do we call it? Cubic. And what's the leading coefficient? What's the first number in front? -2. All right. So you're just supposed to make sure it's in the right order in standard form. If in fact it is a polynomial function, that first term tells you the leading coefficient and the degree, and then whatever degree it is, give it a name. Again, 0 through 5 on the degrees, it has a special name. If it's higher than 5, just say 6th degree, 7th degree, 8th degree, whatever it is. Okay? So far, so good? All right, what do you guys think about this one? Is this a polynomial function? Are our exponents whole numbers? Are the coefficients real numbers? They just have to be real numbers. Is negative 0.8 and the square root of 2 and negative 12, are they all real numbers? Do we have any eyes that you see? You don't see any eyes, do you? All right, so they're all reals, right? So it is, yes, a polynomial function. Is it in standard form yet? No. Brock, put it in standard form, please.
Square root of 2x, the fourth power, minus 0.8x cubed minus 12.
Thank you. So just the square root of 2 is the coefficient. But its exponent was 4, so that should go first. So now we have it in standard form. Okay. So what's the degree? 4. I heard someone say the name. What is it? Quartic. Good. And what's the leading coefficient?
2 squared.
The square root of 2, right? That first coefficient is the leading coefficient once you have it in standard form. Any questions on leading coefficient, degree, standard form? Okay. How about C? Is that a polynomial? No. What says it's not? Yeah, that -1. All right? So that's not a polynomial. Those exponents have to be 0 and towards the positive direction. Okay? So, and no fractions or decimals, no variables either. All right, so that's not a polynomial. How about D? Is that a polynomial?
No.
No. What's the reason?
X.
That X in the exponent. Okay? So they'll try to throw some of that in at you. Just say no if you have that type of problem for homework. All right. So far, pretty easy, right? Okay. Evaluate that function, that polynomial function when x is 3. So what's that mean to do? Just plug 3 in, right? So basically what we're doing is f of 3 means 2 times the quantity 3 to the 4th minus 8 times the quantity 3 squared plus 5 times the quantity 3 minus 7. You can put that in your calculator. You can just do it in your head, however you want. What should I, if I'm doing it by hand, 3 times 3 times 3 times 3 times 3, 4 of them, is 81. And then 3 times 3, 2 of them, is 9. So doing the exponents first, you got an 81 and a 9 there. Doing the multiplication next, what's that? 162, 72, 15, and 7. And then, what's that? 90 plus 1,505 minus 7 is 98. Is that it? But again, you just put in your calculator just like I had written it out there. Okay? We remember how to use these. We didn't forget, did we? We did? Okay? So again, we've got parentheses. How do I raise something to a power? What button? The one under clear. That we call it the caret button, right? So you just do that. You could have hit the squared button for that one if you wanted. Check our work. We got 98. Okay? So you can use your graphing calculator. No problem with that. Okay? So evaluating, that's easy stuff, right? Again, a lot of this is probably Algebra 1 review stuff for you, right? But these are some basics we got to learn as we get into this chapter 4. Okay? So far, so good? Wolf, making sense to you? All right. End behavior. All right? The end behavior of a function is the behavior for the graph as x approaches positive infinity or negative infinity. So the very far right of the graph, what's happening? And the very far left of the graph, what's happening? Okay? For a polynomial function, the end behavior is determined by the function's degree and the sign of its leading coefficient. Okay? Thinking back to our parabolas, how did we know if it opened up our parabola? What was the a value? Positive, right? So our leading coefficient was our a value, remember, in our quadratics, in our parabolas. If it was positive, it had a positive attitude, it had a smile on its face, it opened up, right? What if it was a negative a value? It opened down, it had a negative attitude, a frown, right? Okay, so we're going to think about that on our leading coefficient. All right? So if your leading coefficient is positive, your far right is always going which way? It's positive. Leading coefficient. The far right is always going up. Okay? If your leading coefficient is negative, the far right is always going down. So that's what I look at first. Okay? Oops. That's not what I wanted to do. I want to do it. All right? All right? Sign of the leading coefficient, far right. That tells you what's happening. So the positive infinity end. That's the far right. Okay? All right. So degree is odd. You understand between odd and even numbers, right? So if degree is 1, 3, 5, 7, 9, it's got an odd degree. Right, Nolan? And if your degree is even, it's got a degree of 2, 4, 6, or 8, right? An even number. All right, so for leading coefficients positive, what's happening at the right? Far right's going what? Up. If the leading coefficient's negative, what's the far right doing? Going down, right? If it's odd degree, odd starts with an O. Opposite. Starts with an O. All right? So, not even looking at an actual polynomial right now. If the degree is odd and the leading coefficient is positive, I know my far right is going up. And since it's odd, that means the far left is going opposite, so it's going what? If the far right's up and they're in opposite direction, what's the far left? Down. Okay? You hear what I said? Odd degree, your two ends are opposite directions. Odd O, opposite O. Okay? If your leading coefficient's negative, that means the far right is going down. And we got an odd degree. What does that mean the far left's doing? Going up, opposite direction. Okay? Okay, so that's what's happening here. Look. Far right was going up, far left's going down. Far left is going up, far right's going down. You can tell that by looking at the polynomial right off the bat when it's in standard form. looking at your first term. Look at the leading coefficient. That tells you what's happening at the far right. And then look at the degree. Odd, they're going opposite directions. Okay? Okay? Leading coefficient's positive. So what's the far right doing? Come on. Up. Leading coefficient's negative. What's the far right doing? Down. When it's even, it's the same direction. So quadratics, what's the exponent? What's the degree for the parabolas? 2. What kind of number is 2? Even. What do parabolas look like? Both up, U's, or both down, hills, right? Because the degree was 2, even. They're going in the same direction. Okay? So, leading coefficients positive, even. Far right going up, far left going up. Leading coefficient negative, going down the far right. Even degree means the far left is going down. So, you have a graph that has the two ends going up or the two ends going down when the degree is even. Leading coefficient positive, they're both up. Leading coefficient negative, they're both down. Okay? Questions? So you can do that without even looking at the graph on your calculator if you want. But you can. If you forget, you can always plug it in, right? You guys know how to graph, right? What's the button you start with? Your y equals button, right? All right, so is this in the right order, first of all? Yes. Okay, so all I concentrate on is this leading term, this first term. Okay, so I got a leading coefficient that's negative, and I got an even degree. So I have a quartic polynomial, right? So since the leading coefficient's negative, what's the far right doing? Down. Since it's even, what's the far left doing? Same, right? When they're the same, they go in the same direction. I'm sorry. When they're even, they go in the same direction. When they're odd, they go in opposite directions. All right? If we look at that on our calculator, go to our y equals negative 0.5 x to the fourth plus 2.5 x squared plus x minus 1, and hit graph, are both ends going down? They are, aren't they? Okay. Again, end behavior, this is going towards negative infinity. Oops. Regular 8, not a sideways 8, right? So, negative infinity, and this is over far right, positive infinity. Okay? I just look, if you write the arrows like I'm doing, that tells me you guys know what's going on. Okay? Is this in the right order? Highest degree down to lowest? Okay? So again, all I worry about is that first term. To figure this out, what's the far right doing? going down. Why? That's positive infinity, right? Ooh, that's bad. I'm not very good at my infinities today. And what's my degree? My degree is odd. So what's my far left going to do? Go opposite direction, right? Okay, so those would be opposite directions. If I go ahead and put that in my calculator, negative 0.3 x to the third plus 1.7 x squared minus 4x plus 6 is the far left going up and the far right going down? Yeah. Okay. Also, if you look, if we looked at, this one, I guess I should have brought it out. Okay, but if you remember, this one looked like this. So it kind of went up and down and then up and back down, right? Kind of looked like that. You'll have since there's a degree of 4, you'll have 3 changes in direction, 1 less. Okay? This was going down and then it kind of changed direction. But this had 2 changes because this was a 3. Okay? All right, so this is a positive leading coefficient. So what's the far right doing? Going up. Again, we're just looking at this. Make sure it's in the right order. You got your highest degree. So it's a 5th degree equitic trinomial, so it's only got 3 terms, right? And my far right is going up. And I have an odd degree, so that means far left is down. Okay? So always look at far right first. I look at the positive or negative leading coefficient. And then I look at odd or even. Odd, opposite direction. Even, same direction. Okay? If you need to check, plug it into your calculator. All right? Making sense? All right, so one more thing. You're supposed to graph these. Well, graphing them you can do on your calculator, right? So you can just do it on your calculator. Now, just to give yourself an idea, what's going to be happening at the far right? Down, right? So over here somewhere, the far right is going down. What's happening at the far left? It's going up. Opposite directions, right? So what I would do is go to my y equals and put it in negative x caret 3 plus x squared plus 3x minus 3 and hit graph. And it's doing that, right? Like we thought. It's going up on the left, going down on the right. Okay. How can I get some points to plot so it looks like it's supposed to? What's another way I can look at points? If I know the graph, I can look at its table, right? Hit second graph. And let's here's some positives too. There we go. -3 to +3. Okay. So -2, 3. -2, 3 is there. -1, -4 is here. 0, -3 is there. 1, 0. 2, -1. 3 is off of there, -12. Okay, so we kind of have an idea what it looks like here. Again, something like that. Okay, but you can use your calculator to do those. I'm not going to make you plug in like -2 to make a table. Your calculator will do that for you, okay? So what's going to happen here on each end? They're both going up, right? You guys all agree? Everybody understand why? Even though we haven't really looked at it in our calculator yet? Right? It's a positive leading coefficient. Far right's up. It's even. So they go the same direction, right? So it's going to look like some kind of W probably. All right? So go back to your y equals and put it in there. X, oops, not a 4. X to the 4 minus x to the third minus 4x squared plus 4. So there's kind of a W looking graph. Go to second, oops, not y equals, but second table for some points. So you can plot. -1, 2, those are pretty high. -3, -2, 12. -1, 2 is, get my pen back. -1, 2 is here. -3, 12 would have been up here. 0, 4. 1, 0. 2, -4. And then 3 way down. So it's kind of this. Oh, it goes way down, I guess. 3 goes way down here first and then comes back up. Sorry. So you kind of get an idea. Maybe, you want to see what it does at 4 and 5, maybe. Oh, at 3 it's at 22, isn't it? Not -22. My bad. I had it right the first time. Sorry. And just like we thought, both ends going up. Okay? So use your calculator to help you on the graphing part. You really don't need the calculator to help you on the end behavior, but if you need that, you can do that. Evaluates just plugging it in, right? And then just putting it in standard form, the right order, knowing the names, linear or constant, linear, quadratic, cubic, quartic, quintic on the first spot, 0 to 5, the first 6, I guess. Okay? Any questions? Good start to the second semester in the new year. Good job today.